Hello everyone, for this video we're going to talk about question number 3, that is obtain the estimated of the missing figures using delta and e-shift operator in the following data. So let's get started. We have a table here that you can see which have certain values, which is 2.0, 2.1, 2.2, 2.3, and with respect to all the x value we have some y value. Now to estimate the missing figures using shift operator and delta operator, we need to identify the pattern in the available data and use it to interpolate the missing value. So first we need to find the difference between the x values and the y values. So uh, as the value between consecutive x value we have same, I mean 2.1 minus 2.0 we have 0.1. It would be same for every other differences that we would get. I mean 2.2 and 2.1 difference would be also 0.1. And so we could say that the delta x for every other x would be same. So for now we have the y values. We have to find the delta of differences of y values. And so delta y1 is 1.135 minus 0. As we do not have a value, as you can see here, we do not have a value point for 2.1, which is missing. So for now we have considered it 0. And so the difference between 0.135 minus 0 is 0.135. And then again we would find the second, I mean not the second value, I would just say we would find the value for y2, then y3 and y4. Again for when we say about y4, you can see that we have taken out all the differences between the y values and the x values. Now after calculating all the e values, now calculating all the differences between consecutive x values and y values. Now let's calculate the e value, which are the ratio between consecutive um, delta y and delta x. And so you can see here we have uh, a formula, that is E is equals to delta y by delta x. Here you can see when we calculate the value of of shift operator, we need the y operator, y difference one. I mean the forward difference operator value. I mean the difference value that we have taken of y, and which would be divided by the difference value of consecutive x values. And so after dividing both the values we would get the answer for E. And so for E1 you can see we have divided the value of y1 by delta y1 by delta x, and kept the value that are here, that is delta 1. We know the delta x has the value of 0.1, so we have written here 0.1. And for the y1 value we have 0.1 1.35. And so we have kept all the values we have generated for e1, e2. Let me change the slide. uh, for E3, for E4, and lastly for E5. You can see all the values that I have generated here. And that's it for all the shift operators. Now that we have all the shift operator, let's calculate, I mean let's just interpolate the missing figures. So for the missing figures, now we have estimated value, to estimate the value of y value at the corresponding x value, that was 2.1, we use the e e1 value. So e1 is equals to 1.35, missing number is equals to previous y value. Now where is this previous y we have to take? We have to take this previous y value from our table that is here, that was given to us in a very question. And so we would take the previous value from the table, then E1 value would come from the values that we have generated, I mean the shift operator values, and then with that we would just multiply the delta x. So after doing all these, I mean you can see here, uh, we have done that. We have just uh, calculated the whole thing. You can see, I mean, as per the formula, I have kept all the values and then generated the value that was 0.27. Now for the missing value at 2.4. So to estimate the y value at x is equals to 2.4, we again use this formula. Get the previous value from the from the table that is here, which was 0.1, and just keep the value here with the E4 value that was minus 0.2, we have kept it here, and again delta x value that was 0.1, and then again you have the value there, you have the value which was which is like 0.08. So our missing figures that we required, I'm sorry for that, um, so the missing figures that we were to generate is 0.27 and 0.08. Hello everyone, for this video we're going to talk about question number 3 part C. So the question is, write algorithm program for Lagrange's inverse interpolation method. Now Lagrange's interpolation method I've already taught that in the interpolation part 2 video, which is on my channel, you can check that out. For now, we firstly have to read the value of x that we need to solve our problem. For any sort of interpolation, we always need a set of consecutive x values, and so we need the x, and n is the number of x we would get, number of variables that are being given. And firstly, we need to run a for loop from 1 to n plus 1, so that we could read the value of our x, and with respect to x we would get a function of x which is y, so that we could get our whole table. Next, with this the for would end. After this, a sum would be required. Now, what is the sum? Sum is always is been always required when when we calculate the Lagrange's interpolation. So, firstly, we would create the sum. We would assign the value of sum to be 0. Then we would run a loop from 1 to n plus 1, a outer loop of 1 to n plus 1, and then we have another function that is that we have another variable, I'm sorry for that, variable which would be assigned as 1, and this variable would help us in finding our function of fx, I mean the y that we need, the point where we need the value of fx. And so the first after this we would create another loop of an inner loop of 1 to n plus 1, where we would just keep a value of there is if the value of j is not equal to I. If the value of j is equal to I, the we would not get a desired result, and so now we would write our Lagrange's formula that we have learned in the previous video, that you could see here also, that in the I mean to say in the photo, and then after running this whole loop, when we dry run this, we would firstly check if the number is in between 1 to n plus 1 or not. It would go inside. Then the product function would be assigned with the value of 1. Then an inner loop will learn, it would again check the value, and then until and unless the inner after running the inner loop, uh, every time the product function will change, and then after doing that we would end the for and get the value of sum, as sum uh, is the last procedure for our Lagrange's inverse interpolation. After, you can see here the formula for sum plus f1. F1 is the function that we firstly had, and then firstly, I mean, when we read the first function, that one, and it would be multiplied with the function that we have generated in the last in the previous step, and with that we would get the value of sum. After getting the value of sum, we would write it with the x, and then the whole algorithm will stop.